This is Megan from Online Math Circle AIME video tutorials, and today we're going to look at 2007 AIME II problem number 5. The graph of the equation 9x plus 223y equals 2007 is drawn on graph paper, with each square representing 1 unit in each direction. How many of the 1 by 1 graph paper squares have interiors lying entirely below the graph and entirely in the first quadrant? So first of all, we can draw out the graph. And we see from the equation that the x-intercept is 223, 0, and the y-intercept is 0, 9. And so the region that we want to look at is bounded by the line, the y-axis, and the x-axis. So it's this little region right here, this triangle. Now, the problem asks us to find how many 1 by 1 graph paper squares have interiors lying entirely below the graph and entirely in the first quadrant. So that means we want to count the number of interior lattice points that are inside this triangle. So first of all, for those of you who are unfamiliar with the term lattice point, a lattice point is basically a point where both coordinates are integers. So that means, for example, 1, 1 is a lattice point. 1, 1/2 is not a lattice point because 1/2 is not an integer. So we basically just have to count the number of interior lattice points that are inside this triangle. We can do this by using this formula known as Pick's theorem. Pick's theorem is a way to calculate the area of a triangle based on the number of interior and exterior boundary points that it has. So it says that the area of a triangle is equal to the sum of the number of interior points I plus 1/2 of the number of boundary points B minus 1. So let's look at the Pick's theorem case for this triangle here. So we see that the area of this triangle is 1/2 times 9 times 223, which is equal to 2007 over 2. And the number of basically there are boundary points, 9 boundary points on the y-axis from 0, 1 to 0, 9. 223 boundary points on the x-axis from 1, 0 to 223, 0. And one more boundary point, which is the origin. And there are no boundary points on the hypotenuse because of the fact that 9 and 223 are relatively prime. So that gives us a total of 233 boundary points. So we can basically plug in these numbers a and b into the Pick's theorem formula in order to calculate lowercase I, the number of 1 by 1 graph paper squares that have interiors lying inside the triangular region. So doing that, we get 2007 over 2 equals I plus 233 over 2 minus 1. And then simplifying from here, we get 2009 over 2 plus equals I plus 233 over 2. And so I is equal to 2009 over 2 minus 233 over 2, and that simplifies to 1,776 over 2, and then doing the division, we get 888 as our final answer.